Assalamualaikum and hi. Today we will cover forecasting on curve fitting. Forecasting. What can be forecast? Forecasting is required in many situations. Deciding whether to build another power generation plant in the next 5 years require us to forecast of future demand. Scheduling staff in a call center next week require forecast of call volumes. Stocking and inventory require forecast of stock requirement. Forecast can be required several years in advance for the case of capital investment, or only a few minutes beforehand for telecommunication routing. Whatever the circumstances or time horizon involved, forecasting is an important aid to effective and efficient planning. So let's start with curve fitting method. Curve fitting is the way to model or represent a data spread by assigning a best fit function along the entire range. So remember this, best fit. Ideally, it will capture the trend in the data and allow us to make prediction of how the data series will behave in the future. In previous chapter, you have learned about interpolation. So in interpolation, you connect the data dots. If the data is reliable, we can plot it and connect the dots. And you are using the piecewise linear interpolation method. And it has a limited use as a general function. Since it's really a group of small fx connecting one point to the next, it doesn't work very well for data that has built-in random error or scatter error. So for this chapter, we will cover a solution to overcome this problem. The curve fitting captures the trend in data by assigning a single function across the entire range. The example below uses a straight line function. So we look at the interpolation. So in previous chapter that you have learned about interpolation, you can see that you are connecting the dots. Okay. However, in curve fitting, you will capture the data trends and assign a prediction of the future trend of data. And in this case, for starting, so we will look at a straight line. Use a straight line function fx equal to ax plus b for the entire range. So you can see that the goal is to identify the coefficient a and b such that fx fits the data well, so throughout the range. This is only a sample of data, so we will look forward after this. Another example of data set that we can fit a function to, so we can see several trends of data plotted here. So is a straight line suitable for each of these cases? So we can see here it's a different shape. This is somewhere it can be a linear line. Here can fit a linear line. However, for this one, perhaps no. So yes, the answer is no. Not straight lines is suitable for each of these cases? No. But we are not stuck with just a straight line fits. However, we will start with a straight lines and then expand the concept. We can have several types of fitting occur in our calculation or our prediction. So let's start with linear curve fitting, or we can call it as linear regression. So if given the general form of a straight line, fx equal to ax plus b, so how can we pick the coefficient that best fit the line to data? If we have data 1 over here, 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 and here, so which line is the best for this data? So the first question, what makes a particular line is a good fit? So we need to choose based on this requirement. So why does the blue line appear to us to fit the trend better? So why do we want to choose this blue line? Okay, first we have to consider the distance between the data and point of the line. So if you can see here, so this is a line that we are predicting somewhere here. So we need to check from this point to this line, for example the blue line, okay, this one and this one will have a very minimum error occur between two of them. If you can see in this red line, it is giving bigger error for the prediction. So we add up the length of all the reds and blue vertical lines. This is an expression of error between data and fitted line. And this one line that provide a minimum error is then the best straight line. So that is how we choose which straight line has a good fit to our data. So this method is actually give you the best line has minimum error between line and data point. And this is called the least square approach, since we minimize the square of error. In fundamental, in order to find the minimum of a function, first you need to have derivative describes the slope. Slope is equal to 0 is a minimum. So we take the derivative of the error with respect to a and b and set each to 0. In this case, solve the a and b so that the previous equation both give 0 as mentioned here, and we write these two equations. So here is actually our curve fitting using least square method approach formulae. So this formula is very important in this throughout this exercise. Okay, let's start with the exercise. We will continue in the next video.